Okay, so here we go with an example of a hypothesis testing problem where the claim that we're testing is about a proportion. Biff brags that he knows the answer to more than 80% of all the questions in a popular trivia game. To test his claim, Shirley asks him 50 randomly selected questions, and he answers 42 of them correctly. At alpha equals 0.10, does this verify Biff's claim? In other words, his claim that the proportion of questions he can answer is over 80%, over 0.80. So, step 1, state the hypotheses and identify the claim. The claim that we're testing here is that Biff knows the answer to more than 80% of the questions in the trivia game. So it's a claim about a proportion or a percent, what percent of questions he knows the answer to. So it's about P. Specifically, it's that P is more than, it's over, it's greater than 80%, which in decimal form would be 0.80. So that's the claim. Would that be the null hypothesis or would that be the alternative hypothesis? It's got a, not an equal sign, but a greater than sign, so that makes it the alternative hypothesis. Okay, so then what would the null hypothesis be? Well, it would be that same thing, but with an equal sign. So the null hypothesis is that P is equal to 0.80. So it's not more than 80%. Okay, so that's step 1. Now step 2, compute the test value. Remember what I said that we're going to need for that. We need to know the number in the hypotheses. That was 0.80, or just 0.8. We need to know the sample size. That was 50. That's how many questions that Shirley asked him. And out of those 50, the number that he actually did answer correctly was 42. 42 out of 50. So X is 42. Now, if you're going to be using a graphing calculator's built-in functions or my Excel sheet that you can use or something like that, then these three numbers are what we need. If you're going to be and let me just go ahead and show you how that works. If you're doing this on like a TI-83 or TI-84, press Stat, go to Tests, and the one we want here is one prop z-test. Prop for proportion. And when I select that, we get something like this. And I've already filled in the numbers, but P0 is the number in the hypotheses, 0.80 or just 0.8. X is 42. N is 50. And then we need to tell it what our alternative hypothesis looks like. Does it have a does not equal? Does it have a less than? Or does it have a greater than? Well, it had a greater than. It was that P was greater than this number here, 0.8. So make sure that is selected. Go down here to calculate, hit enter. And our test value Z is 0.70710 or about 0.71. Notice it also gives us the p-value. The p-value, according to the calculator, is 0.239749 something. And it also tells us that p hat is 0.84. Now, if you wanted to use the Excel spreadsheet that I said that you could download from Canvas and use, open that up and go to the tab labeled One Prop Z-Test and fill in the three numbers in these yellow boxes. So this is the same thing that we just showed on the calculator. The P0, the proportion in the hypotheses, was 0.80, or just 0.8. The x was 42. And the n was 50. So it tells us that p hat is 0.84. And the test value z equals 0.7071, so about 0.71. And then, depending on what the alternative hypothesis is, it tells us what the p-value is. Now, our alternative hypothesis was that p is greater than 0.8. It had a greater than sign. So the p-value is 0.2397501. It's very slightly different from what the graphing calculator gave us. I don't know exactly why that is. Maybe a slightly different way that they used to calculate it. But it's really, really close. So it's about 0.2397. Now, what if we were doing this ourselves using the formula? We would have to calculate the p hat ourselves by taking x divided by n. So that would be 42 divided by 50, and that does come out to be 0.84. We would need q for that formula, and that would be 1 minus p. Since p is 0.8, q would be 1 minus 0.8, which would be 0.2. And now here's the formula. Z equals p hat minus p over the square root of p times q divided by n. So for p hat, that's where we put in the 0.84. For p here and here, we put in just 0.8. Q is 0.2, n is 50, and let's see what this looks like on the calculator. Okay, Mr. Calculator, what is, remember I said we need parentheses around the numerator, so parenthesis 0.84 minus 0.8, close parentheses, divided by the square root of, and my calculator automatically put in a parenthesis. If yours doesn't, you want to put a parenthesis here. But inside one set of parentheses, we need 0.8 times, they're right up next to one another, so they're being multiplied. So I'm going to put that in as times 0.2 divided by 50. And then close the parentheses for the square root. And when I hit enter, that comes up as 0.7071 something. So that's our z, that's our test value. If I round it to 2 decimal places, it's 0.71. Now, step 3, find the p-value. When we did this on the calculator or on the Excel spreadsheet, it told us what the p-value was. So if you remember that, or you want to rewind the video, you can see what that was, what the p-value was. If we were doing this ourselves without any advanced technology, we just calculated the test statistic, the test value on that formula. That came out to be 0.71. And then we would turn to table E, and we would look up the z-value that we just found, 0.71. And the number on the table is 0.7611. Now, because our alternative hypothesis had a greater than, we're doing a right-tailed test. So our p-value is not the number on the table, that would be what it would be for a left-tailed test, but instead it's 1 minus that number. So the p-value is 1 minus 0.7611, which comes out to be 0.2389. Now, step 4, make the decision to reject or not reject the null hypothesis. From here on out, this works exactly like the hypothesis testing problems we were doing before. We've got our p-value, we compare it to the level of significance, the alpha. The p-value turned out to be, well, the calculator gave us 0.2397. If we used the table, we got 0.2389. It wasn't quite exactly the same because we got a little bit of round off error when we were using the table, but pretty close. Either way, the p-value is greater than the number we were using for alpha, the level of significance. So when that happens, when you have a big p-value that's bigger than alpha, you would say, do not reject the null hypothesis. So that's our conclusion in step 4. Do not reject the null hypothesis. That's because the p-value was greater than alpha. And now step 5, summarize the results. We said just a second ago that we were going to not reject the null hypothesis. The claim, remember, was the alternative hypothesis. The claim was that p was greater than 0.80. That was the alternative hypothesis. So not rejecting the null hypothesis would mean not supporting the alternative hypothesis, which is the claim here. So there is not enough evidence to support Biff's claim. Is he right that he knows more than 80% of all the questions? Maybe, maybe not. This little test where he had to answer 50 of them and he got 42 out of 50 right, it didn't give us enough evidence to be able to say, beyond a reasonable doubt, that if you asked him all the questions, not just these 50, but all of them, that he would be able to get more than 80% of all of them correct. He might, but just from this sample of 50, we don't have enough evidence to be able to say that.